Hello dear students, welcome back to the online classes. This is the second lecture on the topic sequences and series. In the previous class, we have studied the definition of a sequence, their notations and examples. Also, we have studied the definition of a series, notation and their example. Dear students, in today's class, we are going to study some progressions known as arithmetic progression and geometric progression. Dear students, let me begin with arithmetic progression or AP. Let us recall some formulae and properties studied in earlier classes. Let me begin with the definition of an arithmetic progression. A sequence A1, A2, A3, so on An is called arithmetic sequence or arithmetic progression. If n plus 1th term is given by the formula an plus d, where n is the set of natural numbers, where a1 is called the first term and the constant d is called the common difference of an arithmetic progression. The common difference d is given by the formula a2 minus a1 or a3 minus a2 or a4 minus a3 and so on. That is, the common difference of arithmetic progression d is given by the formula any term minus its previous term. If the constant difference d remains same, such progressions will be called as an arithmetic progression. Let us consider an AP with first term a and the common difference d, that is given by the general formula a plus d, a plus 2d, a plus 3d, a plus 4d and so on. The last term or the general term or the nth term is given by the formula an is equal to or t. We can verify the following simple properties of arithmetic progression. Let me begin with the first property. If a constant is added to each term of an AP, the resulting sequence is also an AP. The second property is, if a constant is subtracted from each term of an AP, the resulting sequence is also an AP. Similarly, the third property, then the resulting sequence is also an AP. The fourth property is, if each term of an AP is divided by any non-zero constant, the resulting sequence is also an AP. These are the simple properties of arithmetic progression. Now here we shall use the following notations for the arithmetic progression. A is called the first term, L is the last term, D is the common difference. N is equal to the number of terms and Sn is equal to the sum of n terms of AP. Let a plus d, a plus 2d, so on, a plus n minus 1 into d be an arithmetic progression. Then the last term tn or an, or it will be denoted by the notation L, is equal to a plus n minus 1 into d. With these definitions, today we are going to solve some, but before that let me give one simple formula to find sum to n terms of the arithmetic progression, and it is given formula Sn is equal to n divided by 2 into 2a plus n minus 1 into d. We can also write Sn is equal to n by 2 into a plus 2a can be written as a plus n minus 1 into d. But a plus n minus 1 into d is our L, therefore L plus a, which is equal to n by 2 into a plus n. Dear students, we will start with some of the examples based on the arithmetic progression. Find the sum of odd integers from 1 to 2001. The numbers are given from 1 to 2001. We have to select the odd numbers and their sum. The odd integers from 1 to 2001 are 1, 3, 5, 199 and 2001. This sequence forms an AP because the first term is a is equal to 1. The common difference of any two terms always remains constant, that is 2. Therefore, this progression is called as arithmetic progression. Here the first term is 1. The common difference of the any two term is 2, which remains constant. And the last term of this sequence is 2001. Therefore, Tn is 2001 and it is given by the formula a plus n minus 1 into d. A is 1, n minus 1 into d is 2, which is equal to 2001. By solving this equation, we get 2n minus 2 is equal to 2001 minus 1, that gives 2000. Therefore, 2n is equals to 2000 plus 2, that gives 2002, divided by 2, that gives n is equal to 1001. Meaning is the 2001 is the 1001th term. I got the which term is this 2001, which is nothing but 1001th term of this progression. But the question is to find the sum to these many terms, 1001 terms, and it is given by the formula Sn is equal to n by 2 into 2a plus n minus 1 into d. Therefore, here n is nothing but our 1001 by 2. 2 into a is 1 plus n is our 1001 minus 1 into common difference is 2. By substituting these all values, we get Sn is equal to 1001 divided by 2. 2 ones are 2 plus 1001 minus 1 is 1000 into 2. Therefore, their product and the sum gives 2002 divided by 2. Once again, it gives 1001 into 1001. That gives 10 lakhs 2001. The sum of odd number from 1 to 2001 is 10 lakhs 2001. Dear students, let me begin with the second question. Find the sum of all natural numbers which are lying between 100 and 1000, which are multiples of 5. These numbers are multiples of 5. Let me begin with the answer. The natural numbers lying between 100 and 1000, which are multiples of 5, are first number lying between 100 and 1000 in multiples of 5 are 105, 10, 15, so on. The last number between 100 and 1000 multiples of 5 is 995. In this case, the first term is a is equal to 105. And the common difference between any two root term is 5, and the last term of this sequence is 995. Therefore, the Tn is given by the formula, or An is given by the formula a plus n minus 1 into d, which is equals to Tn. But Tn is already given to you. Through this equation, we are supposed to find the which term is 995. Therefore, the first term is 105 plus n minus 1 into common difference is 5, which is equal to 995. N minus 1 into 5 is equal to 995 minus 105, that gives in 890. Therefore, 5n minus, or we can write n minus 1 is equals to 890 divided by 5, that gives 178. Minus 1, let me bring it to the right side. Therefore, the nth term of this sequence is nothing but 179. That is, the 995 is the 179th term of the given arithmetic progression. But in this question, we should find the sum of all these 179th term, and that will be given by the formula Sn is equal to n divided by 2 into a plus n minus 1 into d. But our n is just now we found 179 divided by 2. 2 into the first term is 105 plus nth term is 179 minus 1 into common difference. Therefore, 179 divided by 2. 2 into 105 plus 178 into 5, because 179 minus 1, that gives 178. Therefore, once again by writing this 179 divided by 2, we can write this as 105. 2 common will be taken from the above equation to get cancels. Therefore, 105. 178 divided by 2 gives 89 into 5. 179, 105 plus 89 into 5, that gives 455. Therefore, their additional product gives 98,450. Therefore, the sum of the first n natural numbers which are lying between 100 and 1000, which are multiples of 5, is 98,450. Dear students, let me begin with another example. Question number 3. In an AP, the first term is 2, that is A is 2, and the sum of the first 5 terms is 1/4 of the next 5 term. Next 5 terms. Show that 20th term of this given progression is 112. Dear students, in this problem we have been given the first given sequence is A is equal to 2 is given to you. The common terms of the AP that we consider as a D. Therefore, the progression is 2, first term is 2, second term is 2 plus 2, third term is 2 plus 2D, fourth term is, that is fifth term, 1, 2, 3, 4, term is 2 plus 3D. But it is given that sum of the first 5 term, that is 1, 2, 3, 4, and gives 10 plus 10D. Similarly, the sum of the next 5 terms is again given by the formula. It is A plus 5D, A plus 6D, A plus 7D, A plus 8D, and A plus 9D. Their sum gives 10 plus 35D. According to the given condition, the sum of the first 5 term is 1/4 of the sum of the next 5 term. That is 10 plus 10D is equal to 1/4 times 10 plus 35D. By cross multiplication by 4, we'll get 10 fours of 40, 10 fours of 40D, and which is equal to 10 plus 35D. Solving this equation, we get the value for D, and D is nothing but the -6. The first term of the given sequence is 2. Through this equation, we got D is -6. Now it is easy to find the 20th term of the given progression, and 20th term is given by the formula A20 or T20 is equal to A plus n minus 1 into D. A is 2 plus 20 minus 1 is 19 into -6, that is 2 minus 114, which is gives minus 112. This, the 20th term of the given arithmetic progression is minus 112. Dear students, we start with solving the fourth question. How many terms of the AP -6, -11 by 2, -5 and so on are needed to give the sum -25? One sequence is given for us, one progression is given for us. We have to find how many terms of the AP whose sum gives -25. Let the sum of n terms of the given progression is -25. It is known that Sn is equal to n by 2, 2a plus n minus 1 into d, where n is the number of terms, a is the first term, and d is the common difference. Here a is -6. The first term of the given progression is -6. That is, any term minus its previous term. Any term, second term is -11 by 2, and minus of the first term is -6, which gives +6. By solving this fraction, I will come to know the d value. D is equal to 1 by 2. Therefore, we obtain Sn is equal to n by 2 into a plus n minus 1 into d. And Sn is given for us -25. The number of terms we do not know, we should have to find out. Therefore, n by 2 as it is, and it gives 2 into first term is -6 plus n minus 1 into d. D just now we got it as 1 by 2. The common difference is 1 by 2. Therefore, by cross multiplication, 25 into 2, that gives -50 is equal to n, and by solving this equation, -12 plus n by 2 minus 1 by 2, that is -50 is equal to n. And by solving this equation, n by 2 as it is, -12 minus 1 by 2, that gives -25 by 2. Therefore, the common denominator of these two fractions comes to the left hand side. -100 into 2, -50 into 2 will be -100, which is equal to n into -25 plus n. By solving this equation, we get a quadratic equation in n, that is n square minus 25n plus 100 is equals to 0. By solving this by factorization, we get the factors as n into n minus 5 minus 20 into n minus 5, which is equal to 0. Therefore, the factors are n minus 5 into n minus 20. Therefore, n is equal to 20 or 5. Therefore, the sum to 20th term or the sum to 5 term gives the value of series or the sequence is minus 25. Therefore, n is 20. I hope you have understood the today's class, that is the arithmetic progression, their symbols, notations, formulas and examples. Hope you will practice this. Thank you. Stay home, stay safe.